Hello and welcome to this video on classes in our introduction course on programming. So this is basically the last module before the certificate is given. So I'm going to go through a little bit what classes are. So what is a class? Well, a class is a representation of something. That's an important word here. Represent either a real world object, but more often than not, some concept in the code. Let's call it representation. So you write a class in the code, and then you can instantiate it. So then you will get an object or an instance of the class. And once you've written your class definition, you can instantiate it many times. So in our case, we're going to work with characters. So if you write the class character, you can instantiate it and create many variables of the type character. So class definition, when you have an object, an instance of it, becomes it's of type character. The class is also the type. You can also say, one of the points when you have a function which we just had in the last module, is that you're able to give something a name and it has a specific function. So I think that is one reason specific, let's say, task or function or so. So that's one of the points of why classes and object-oriented programming, which is connected with classes, is a good thing in programming. Because instead of having, like I showed last time in the function video, instead of having a long stretch of code, which is very hard to read, you can break it apart into smaller parts. So a class can be such a part of the code, a code block, that does something specific. And you can also give it a name, like character that we're going to work with here. So then you create objects of that class that can do specific things, and it's very predictable what it will do given the name of the class and the name of the methods that it has and the name of its attributes or variables that it holds. So a class basically has also parts of a class, we can say. The main parts would be attributes or variables. So a class can hold a string, can hold a boolean, can hold any other class, any other type. And those are attributes that are connected to the class. So in our case, we're going to have a character, and the attribute we use is color. And it can also have operations. So operations are basically functions that are attached to the class, or methods as we call them when they are on a class. So those are things that you can ask the class to do. In our case, we're going to have a character and we can ask it to say something. So the method we attach is say. And if we look, there is something called UML, Unified Modeling Language. So in our case, and what it's used for is to describe a class like in a visual fashion, we can say. So in our case, we're going to have a class character. So that goes in the top box. That's the name of the class. And then below it, we have color, which in our case is a string. So in the second box, we add any attributes or variables that are attached to the class. So we would say in the end something like character.color to access that one. Except now I draw a little minus sign here, and that is meant in UML to denote that it's private. So this is the typical way that you do it. The attributes are not reachable directly, so they put a minus. A plus would signify that it is accessible. So the next one we have get color, for example, or set color. That's an operation or a method. So what do we have here? We have a name, we have an attribute, and we have an operation that you can do on the class. So we will see soon how the character looks, and then we can see that you can get the color or set the color on the class. That's the idea. So again, it's also connected to object-oriented programming classes. That's an important thing. OOP, object-oriented programming. So if we move on then to level 1, where we're gonna basically start to create this character class, and we're gonna make it white. So as long as you make the character Skilly white in this case, it will look like this. So if we go to the code, we want something like this. And usually I use Python as an example language, as that's my favorite, personal favorite. But in this case, since Java is so connected to classes and maybe arguably has a more nice or beautiful way to write classes, I will use Java as an example here. So this will be our class character, and then we define some attributes or variables that are connected to the class. So in our case, we have to have an API, because that's how we actually do things in the graphical canvas, meaning the one I showed here. So that one is more of, it's more of something we have to have. Then we have an integer called index, because we're going to use 2 or more characters later, and then we want to give them a unique index. And then we have what I drew in the UML. We have a color, which is a string. The default here is set to blue. Then we write public character. So this is the constructor. So in the end, all classes needs to have a constructor or something which creates an object instance from the class. And this is basically the code that's always run when this happens. So when we, as you can see down here, we're going to write variable car1 is a new character. So in Java, the new keyword means we create a new instance of this class. And then this constructor will always be called. And it requires, in this case, an API to be sent and an index, an integer. So we send the API, we send an index there. And then we do certain things. We attach those, we save those values that you send as input to the class. Basically set these attributes or variables to whatever was sent. That's a very typical thing to do in the constructor. And then we're going to add set color. So that's the operation or a method, something you can do on the class to alter it. In this case, you're going to be able to set the color to a different color. It starts off as blue, but you can send in a new color, and then we will set it like this. And we have to also tell the API that this index, this character has a new color. That's to be able to show things in the canvas that we just saw. Then once you have this class definition, this piece of code here, you can instantiate an object. So in Java, all classes are actually subclasses of objects. So they are all objects in the end. That's a side note and may vary depending on language. So then we say that this.car1 is a new character, and we send in the API and the index we want to give. And then we set the color to white. That was the requirement in class 1. And then we will do something like this and pass the first level. So in this demonstration video, I'm not going to actually run the code and kind of do the coding, but instead I'm going to basically talk about what you should do. But I should also say that a lot of the code is given to you here to the left in the description. You will get basically the class code that you should add here at the top. Maybe you need to do some minor changes, but it's basically all given. And actually in this case also the code that you need to do to run to pass the level. And as you will see here to the left, there is a description. And when I change from, for example, Java to Python, you will see how classes are defined in Python. Should be some indentation here also, but okay, we'll leave some work to you apparently. Then we also have, let's say, C#. It's also popular language. And then class is defined like this instead. And this is the code to do an instance of a class. So that's what you should do in level 1. Define a class and instantiate it. And it will basically go, I've done the Java example, so it will basically go on top here, is the idea. So then if we go back here, we're going to talk about level 2. Level 2 then deals with inheritance. So the idea with cat and dog here is that if you have the character class at the top, the one we just drew. I'm not going to do the full UML now, but then we have a cat class here and a dog class here. And they will both be, as you see, it says here that they extend character. This is different in different languages. You can see in level 2, we can try it right after this, change the language and see how you do inheritance in different languages. But here in Java we say extends. So what it means is that cat is an instance of class character. So it means that it by default gets the properties that we just saw. We set color on character, for example, and we can define get color, set color, for example, on the character class. And then since both cat and dog can also have colors, they benefit from this. They don't have to also write that code. It's already in the character class. So why do we do a cat and a dog class? Well, in this case, we can do something more specific. So in the API, we have set skin. So we're going to set the skin of the character at hand, index at hand, to cat. And there is also dog skin. It will look something like this, as we see here. We have a cat and a dog. So we have a character behavior, we have a character class, but they have something specific to them, like this. And this is called inheritance. And then in the code, in the Java code, it might look like something like this. We recognize this from before. We still have the same attributes here. We have the same constructor, and we have our set color or get color. Let's use just one example here. So we have set color. Then we write class cat extends character, and we write a new constructor for cat, which calls super API index, means that it reuses the constructor up here. That's also very common in all languages. Sometimes you want to call it before your additional code or after, but we also have some additional code. So in this case, we set the skin so that the character then looks like a cat in our canvas. And for the dog, it's very similar. We call the same constructor as before, so API and index will be saved. And then we set the skin to the dog skin here. So this is the code to inheritance and create child classes to the character class. And this is what it looks like then in the canvas. So when we instantiate it in level 2, we were told to do an instance of class cat called, in this case, car1 we call it. Could have been called cat also as well, but now we used car1. For index 1 we create a cat, and then we set the color to yellow. So to remind you, set color was defined here in the parent class. There is set color, so we don't have to redefine it in the cat class. We can instantiate it as a cat, and since that is a child which has character as parent class, we can use the set color method and set it to yellow here. We also create a dog, which also inherits from character class, and there we can also set the color to red. And then this is what we get. We get a yellow cat and a red dog, like so. So that is what we want to have in, if we go to level 2 here, we can also click to level 2, mostly to show that you get the code here as well for doing child classes or extend the parent class. If I change from Java to Python, you see how to do that in Python, and we can also do it in C# as another example, how to create a class that extends a parent class. And then it looks like this. If I would run the code here, no, not that one actually. Let's go to Java and run that code. Let's run that code on Java. Yeah, there we have the Java version where we extend the parent class and create a yellow cat and a red dog. So moving on to level 3. So level 3, we're going to talk about polymorphism. So that's a common word in relation to object-oriented programming. What it means is basically that you have a class that exists in different forms with different behaviors. So we already actually have, you can say, polymorphism when we define cat and dog. since they were set with different skins. But even more, maybe more classical example of polymorphism is when you have something like this. When you have a say class in the parent class. You have a say method in the parent class where you say a string like this one. But then in the child classes we redefine say. So that's the polymorphism part. This cat is still a character. It passes the test. Cat is a character. And dog is a character. If you have an instance of cat, then it would also be an instance of character. So we know we can do say. But we redefine it here for cat. So cat will apparently say the text, but it will add meow to it. And a dog will still also say the text that you send in, but it will add a woof at the end. Apparently, that's how those animals work in our example. So each type can provide its own independent implementation and override the behavior in the parent class, in the character class in this case. So, yeah, maybe we can do a UML version here, just a little bit of a simplified one. We have character here, we have cat, and we have dog. So the point is that we have say up here, but in the cat class we override it. So we also have say here. And in dog class, similarly, we have our own specific say method, which overrides the character class. So that would be the polymorphism part, that we have our own versions of things. And I also mentioned another one, that all Java classes extend in the end an object class. So they can say that all classes by default in Java use polymorphism in a way. So here is level 3 where we should implement say. So then in this case I'm using the level 2 method to create the characters, the yellow cat and the red dog. And then I send in the say command, I am Katniss, but it adds a meow. And in character 2, the dog, I say I am Douglas, the name of the dog, and it adds the woof at the end. And that's how to pass level 3. So if we look here in the code, we can go back to let's code now. And we have a Java version of things here. And if I would run code, we can see an example of that polymorphism here. Yeah, basically what I just showed. And I can also mention again that you can just change the language here. You will see how to add the methods to the cat and the dog class in Python and in C# using these examples here. So that is our exercise, our module on classes. Good luck in solving it.